Yes. Good afternoon all my dear students. Hope all of you are fine, doing well. Welcome all of you to the Chemistry Avanti NEET Crash Course 2026. So students, today as we discussed in the last class, today we will be discussing about the solutions chapter. Hope all of you have done a quick revision of this chapter and so that we can run this crash course very smoothly. So dear students, today we will be discussing about the solutions chapter, and the major important topic that we will be covering in the today's class is concentration time. First one is concentration time, but I am so sorry students, I won't be covering this topic. Why I won't be covering? Because this already I have covered in the mole concept chapter. So everything, all these things I have covered in the mole concept, so I won't be covering this particular portion. Next I will be covering is about solubility I will be covering, and after that we will be moving into the vapor pressure and Raoult's law. We will be moving into vapor pressure and Raoult's law. Okay, then what is the next? Next we will be discussing about the azeotropic mixtures. Which are the azeotropic mixtures? Yeah, positive deviation, negative deviation, all these things we will be discussing. Next we will be discussing about the very important topic of this chapter, that is colligative property. What are the different colligative property and what is the equation, and all these things we will be discussing. And the last one we will be discussing is about abnormal molecular mass, abnormal molar mass. In that abnormal molar mass, the important points like Van Hoff factor, degree of dissociation, degree of association, all these things we will be discussing in this particular topic. Okay, yes. So the first portion that we will be discussing in today's topic is Henry's law. So students, Henry's law, all of you know that when I am mixing a gas, example we can take a soda gas, the gas will be dissolved in the solution, right? And what is the theory behind this one? That is nothing but the Henry's law. According to Henry's law, the solubility of a gas in a liquid is directly proportional to the pressure that is applying onto it. From that we can got the equation of Henry's law. P is directly proportional to chi. What is chi? Chi is the solubility, or it is the mole fraction of gas in a liquid. That is, mole fraction will be telling you how much amount of gas will be there in a particular amount of solvent, and that is nothing but our solubility itself. Okay, now what are the few points you have noted down for this one? We know that partial pressure is equal to Kh into mole fraction, and remember the relation between Kh, which is the Henry's law constant, and this mole fraction. According to this equation we can say that mole fraction is inversely proportional to Henry's law constant, which means if a gas is having higher Kh value, that will be having lower solubility. Yeah, that's the point I want everyone to take a note here. Now we can also go into the graphical representation. What is the graphical representation? We know that P is equal to Kh into mole fraction, and this equation is similar to the equation of what? Equation of straight line, in which Kh is a slope, and if I am drawing the graph of pressure versus mole fraction or solubility, I will be getting a straight line. With a zero intercept. And what is the slope? What is a slope here? Slope is nothing but our Kh value. Got it? From this we will be understanding that higher the slope, higher will be the Kh value, and lower will be the solubility. That is the point I want everyone to take a note in this particular section. Okay. Now how the temperature is related to solubility, that already we have discussed. We all know that why we are keeping the carbonated or the soft drinks or the cool drinks in a fridge. Of course, it is because to avoid the bursting of the bottle, right? If we keep in a higher temperature, what is going to happen? The gas inside the bottle will come out. And it will burst the bottle. That is why we are not keeping the cool drinks or the carbonated drinks in the high temperature. Okay, that is, solubility of gas is inversely proportional to temperature, and this is the main reason why aquatic species are more comfortable in cold regions or in cold water, because in cold water there will be more dissolved oxygen is there in cold water, so aquatic species are more comfortable in cold water. If we increase the temperature, what is going to happen? The dissolved oxygen will be coming out, in which they will be feeling breathing difficulty. Got it? Yes. Now another important application of Henry's law constant. What is this? It is a condition which we can call it as bend. What is this condition? Bend. What is this condition? Can anyone let me know? Yeah. What is this condition is that we know the scuba divers will be go deep into the sea, right? If you go deep into the sea, what is happening to the pressure? Pressure will be higher. At the higher pressure, according to Henry's law, the amount of gas which will be dissolved will be higher, right? So at the higher pressure, the nitrogen or the oxygen mixture of the cylinder which is present on the back of the scuba divers, that will be mixed into the blood. And what is going to happen is when they come out from the surface, the pressure will decreases. When pressure decreases, there is a high chance that these gases will be start coming out from the dissolved blood, which will lead to a condition called as bend. That is, and to avoid this bend, we will be using, instead of nitrogen, normally a oxygen cylinder will be having nitrogen and oxygen, but as nitrogen is having higher solubility in blood, we will be avoiding nitrogen and we can use helium. Helium will be having low solubility in blood, so it won't be causing that much of problems for the scuba divers. So these are the important applications of Henry's law. Now I want to add one question which can come in the NEET exams. Yeah, arrange the following. Arrange the following in the order. Arrange the following in the order of what? In the order of arrange the following gases. Arrange the following gases A, B and C in the order of their solubility. Okay, and the question is like they will be giving the graph of pressure versus solubility, and these are the graphical representation of the three gases A, B and C. Now the question is, among these which is having higher solubility? That is the question. How you will be solving this one? Just now we have discussed. The slope will be telling you which is more soluble. That is, slope is nothing but KH value. Slope is KH value. Higher the slope, lower will be the, and KH is inversely proportional to the solubility. Higher the slope, lower will be the solubility. So among these which is having higher slope, by looking itself we can understand that line which is more inclined towards y-axis, that is having more slope. Yes or no? Yes. So among these we know that the C is the one which is more inclined to the y-axis, so that is having higher slope or that is having lower solubility. So and then we can see B, then we can say it is A. So the order of solubility is T is A greater than B greater than C. Okay, the slope which is mentioned here, that is KH only is a slope. And not only from that KH value, we can also find it by using by checking it from the line. That is, if I am just drawing a straight line, you can see that A will be having mole fraction. A will be having more. Just a minute. Just give me a minute. Okay, if I am just taking the A, like you can see the more A will be more soluble. A will be more soluble in the water. So yeah, by looking at the graph, we can say the A will be having more mole fraction. Then comes B, then comes C. So it is very clear from the graph that A is having more solubility. So this is one of the point I want everyone to take a note of it. Yes. Now we will be moving into the next, that is vapor pressure. Vapor pressure is actually very important concept here. Why it is very important? Because most of the things are related. Most of the things that we are going to discuss after this is related with vapor pressure. Okay, I will be telling you a quick idea how we can understand vapor pressure. Just take a water bottle. All of you know, right? If we keep this water bottle for some period of time, what is going to happen? We can see small tiny droplets of water. You can see, right? You can see small tiny droplets of water surrounding this water bottle, right? Yeah. And my question is this water droplets only present on the side of water bottle? No, it's not only actually present on the side of water bottle, it is also present above the surface of liquid. It is also present above the surface of liquid. But what we can see is that is present on the side of bottle. So this water vapor which is present above the surface of liquid will be applying pressure to the liquid. Above the surface of liquid there will be water vapors or vapors that will be applying pressure to the liquid when these two are in equilibrium with each other. When these two are in equilibrium with each other, that is what we can call it as vapor pressure. And this vapor pressure concept we will be applying only in the case of closed container. Only in the case of closed container. In the case of open container, the vapors which is above the surface of liquid will evaporate or will escape. So we can't apply that one. Yeah, this is the complete idea about vapor pressure. Now how it is related to boiling point, temperature, intermolecular force and all these things, that we will be discussing right now. Okay, this vapor pressure I can say directly proportional to temperature. Why? What is the reason? What is the reason? If I am increasing the temperature, more vapors will be forming. If more vapors form, more pressure will be applying on the surface. Yes. Now it is also dependent upon volatility. It is also dependent upon the volatility of a liquid. If the liquid is more volatile means easily it can convert into vapor. If it can easily convert into vapor means more vapors will be forming. More vapors will be forming means more pressure will be applying on the liquid. So it is directly proportional to volatility, and it is inversely proportional to intermolecular force. It is inversely proportional to intermolecular force. Why it is inversely proportional to intermolecular force? If the intermolecular force is stronger, it's very difficult for the molecule to convert into vapor phase, right? If the molecule is not converting into vapor, there will be less vapor, and if it is less vapor means less vapor pressure. So that is why vapor pressure is inversely proportional to intermolecular force. Smaller the intermolecular force means more vapors will be forming and higher will be the vapor pressure. And how it is related to boiling point? How it is related to boiling point? I hope all of you know what is the exact definition of boiling point. Boiling point is, what is boiling point? It is the temperature in which vapor pressure of a liquid become equal to the atmospheric pressure. Vapor pressure of a liquid become equal to the atmospheric pressure. That temperature is, this temperature is nothing but our boiling point. How much temperature is required? For the vapor pressure of a liquid to become equal to the atmospheric pressure. That is what boiling point. Okay, if the vapor pressure is very higher, if the vapor pressure is already very higher, it need very less temperature, right? It need very less temperature to make it equal to the atmospheric pressure. And what is that less temperature means? That less temperature is the boiling point. The less temperature is nothing but the boiling point. So that is why I can say vapor pressure is inversely proportional to boiling point. That is, if higher the vapor pressure means we don't need to supply more temperature to make the vapor pressure equal to atmospheric pressure. So the boiling point will be less. Got it? So this is the complete idea related to the vapor pressure. Yeah, hope all of you got the clear understanding about vapor pressure. Now we will be moving into the next, that is Raoult's law. Raoult's law, which is applicable to ideal solution. A solution is ideal only if it obeys Raoult's law. And what is Raoult's law? Consider I am having a two liquid A and liquid B, and let's suppose liquid A is having a vapor pressure P naught A, B is having a vapor pressure P naught B. Okay, now what I will be doing, I will be mixing these and I will be making a solution having AB. This is solution. And my question is, what is the vapor pressure? What is the vapor pressure of the solution? That is my question. That is the total pressure of the solution. The total pressure of this solution will be equal to sum of the partial pressure of solution liquid A and B. Actually here it should be sum of vapor pressure, but when it coming into the solution, we will be replacing this vapor pressure with the partial pressure. Okay, this is about ideal solution, Raoult's law. Okay, now few more points I want to add is, for an ideal solution, how we can say whether this is forming an ideal solution or not. For an ideal solution, A interaction will be equal to BB interaction, which will be equal to AB interaction. That is, if AA interaction, BB interaction and the AB interaction all are same, if all these are same, then we can say the solution is ideal solution. Actually, we all know that ideal things are very rare to find out, right? Ideal things are very difficult to find out, and a very dilute solution only can form a ideal solution. Okay, now any other point, for an ideal solution, the delta H will be equal to 0. That is when we mix two solutions, there should not be any absorption of heat, or there should not be any release of heat, and also delta V mix is also 0. That is, there should not be any change in volume after mixing. Then any other points? What about delta G? Delta G of mixing should be less than 0. Why it is less than 0? Because we all know that spontaneous process, delta G should be less than 0. Then only mixing will be taking place. It should mix. For mixing, it should be spontaneous. And then delta S. What about entropy? Entropy should be greater than 0. Because when we are mixes two solution, number of molecules is increasing, their collision is increasing, so entropy, the randomness also will be increasing. So this is the small idea about Raoult's law. Now we can just go into the equation. Yeah, PS will be equal to P naught A chi A. That is, PA is equal to, PA I can make it as P naught A chi A, and PB will be equal to P naught B chi B. Okay, this is one of the equation you can use to find out total pressure of a solution. Okay, now my question is, how we can make one more equation with respect to any one of the mole fraction. Any one of the mole fraction, if I am using, how will be the equation? That is, we all know that chi A is equal to 1 minus chi B. Chi A is equal to 1 minus chi B. And by applying chi A is equal to 1 minus chi B, I will be getting total vapor pressure of the solution is equal to P naught A plus chi B into P naught B minus P naught A. Okay. Yeah, this is the one more equation. I want everyone to take a note of it for the total pressure of a solution. Yeah, the two important equation, that is PS is equal to PA plus PB, and the another equation, PS is equal to P naught A plus chi A into P naught B minus P naught A. Yes, so the complete idea about Raoult's law is here. All of you take a note of it. Now we can move into non-ideal solution. Ideal solution we have discussed, and now is the time to discuss about non-ideality. Okay, for non-ideality, yeah, everything I have mentioned here, comparison of ideal and non-ideal. Ideal solution already we have discussed. A solution which obeys Raoult's law is ideal solution, and if a solution is not obeying Raoult's law, they are non-ideal solution. And this non-ideal solution can be of two types: the solution which is showing positive deviation and the solution which is showing negative deviation. In the case of positive deviation, the vapor pressure or the pressure of the solution will be higher than that we expected, higher than the calculated one. They are positive deviation. In the case of positive deviation, the interaction A-B interaction will be lesser than AA or BB interaction. That is, after mixing, when we form a solution, after mixing we will be forming a solution, and the intermolecular attraction of that solution will be lesser comparing to the intermolecular force of attraction of the individual liquid. Okay, and due to that one, the vapor pressure will be higher than that we expected, because the intermolecular attraction is lesser, right? Intermolecular attraction is lesser. We just now we discussed that vapor pressure is inversely proportional to intermolecular attraction. So as the intermolecular attraction or interaction is lesser, the vapor pressure will be higher. Okay, and what about the enthalpy? enthalpy will be positive, that is delta G will be positive, because we know that it is happening, it is forming a bond, right? It is forming a bond which is less interaction. So to break that bond we need to supply energy, so it is positive. And what about delta V mixing? Delta V mixing, it will be positive. Why it is positive? Because we all know that when we mixes together, when we mixes two solution, and if the intermolecular force is lesser, means the bond length will be higher, right? So the resultant solution will be having an expansion, or the volume of the resultant solution will be higher than that we expected. Okay, and the examples ethanol plus acetone, this is the one of the example, you can note it down. Got it everyone? Okay, hope all of you understood, especially this endothermic. Why it is actually endothermic? We know that the stronger bond is converting into stronger bond, strong is converting into weak, right? Stronger bond is converting into weak. To make stronger bond to weak, we have to supply energy. And that supplying energy process is what we call it as endothermic process. Now when it coming to the negative deviation, here the resultant solution, that is AB solution, will be having an intermolecular interaction higher than the individual components interaction. Not this one. And as the interaction is higher, or the molecule is tightly closed or tightly attracted, because of that it can't easily convert into vapor. Which result in the less vapor pressure. So vapor pressure will be lower than that we expected in the case of negative deviation. Now what about delta H mix? Here what is going to happen? We are getting a stronger bond, that is weaker bond is converting into a stronger bond. When weaker bond is converting into stronger bond, there will be attraction is happening, right? There is attraction is happening. When there is an attraction, what's the point? When there is an attraction, there will be release of energy. That is why delta H mix is negative for negative deviation. And what about delta V mix? Yeah, delta V mix will be negative. Why? Here there will be contraction. After mixing there will be decrease in the volume of the solution. Why it is happening, students? Why it is happening? Because it is very clear. The weaker bond is converting into stronger bond. When it becomes a stronger bond, the molecules will come closer, and when it comes closer, the volume will be decreasing. Okay, so that is clear. Now the example you can note down, chloroform plus acetone. Chloroform plus acetone is the example, you can note it down. So my dear students, this is the complete idea about Raoult's law and its deviation from the ideal behavior. All these things I have clearly mentioned here, and one of the common thing in all these things, is for all these solution, delta G mix is less than 0 and delta S mix is greater than 0. That is one of the common thing in all the type of solution, ideal solution, non-ideal, and the one which is showing positive deviation and negative deviation. Hope it is completely clear to everyone. Yes. Now we can move into the next. What's our next? Next is azeotrophs. What is azeotrophs? Constant boiling mixture. What does it mean? What is the idea behind it? Let's suppose if I am mixing a two solution. That is, after mixing I will be getting a solution having molecules A and molecules B. Got it? Okay, now if I am heating this one, what you can see? If I am heating? What you can see? Depending upon the boiling point, depending upon which is having higher boiling point or lower boiling point, evaporation timing will be different. That is, if A is having lower boiling point, they will be evaporating first, and then comes only B. That is how when we are heating the process will be happening. But if he mixes in a particular ratio, if AB mixes in particular ratio. If he mixes it in a particular ratio, what is going to happen, my dear students? If he mixes in a particular ratio, instead of going it separately, they all will go togetherly. They all will go togetherly. That is, when we mixes in a particular ratio, they will be forming a particular bond, and that will be making them to move togetherly when we heat. It will be having a single boiling point. That is what azeotrope is meaning. Got it, everyone? I can say some examples. Example of minimum boiling azeotropes. Minimum boiling azeotrope. What is the example? What is the example I can give? 95.6% ethanol and 0.4% water. What is minimum boiling azeotropes? Azeotropes are of two types. One is minimum boiling azeotropes, another one is maximum boiling azeotropes. What is minimum boiling azeotropes? They will be forming a solution with a large positive deviation. Large positive deviation means what? Vapor pressure will be higher. If vapor pressure will be higher, what is going to happen? Boiling point will be lower. That is why minimum boiling that is why the solution which is forming large positive deviation, they will be minimum boiling azeotropes, and the solution which will be large negative deviation, they will be forming maximum boiling azeotropes. And one of the example I can give for maximum boiling azeotropes is 62% HNO3 and 68% HNO3 and 32% water. So students, this is the complete idea about azeotropes. Azeotropes, they will be boiling in a constant boiling point rather than going separately. Okay, and this will happen only if he mixes two liquids in a particular ratio. Moving to the next one is the important part of this chapter. I hope all of you have an idea about this colligative property. I am not going much deep into each and individual colligative property. I will be just going into the equations of colligative property. First one is relative lowering of vapor pressure. Relative lowering of vapor pressure, the colligative property is what? When we add a non-volatile solute into a solution, what is going to happen? Vapor pressure will decreases. And what is the equation for relative lowering of vapor pressure? P naught minus Ps divided by P naught. It is equal to I into mole fraction of solute. What is I? I is the Van Hoff factor, which we will be discussing after some time. It is a correction factor to correct the molecular mass when there is a electrolyte present in the solution, or if I am adding a non-volatile electrolytes, at that time the molecular mass that we are getting is not going to be a correct molecular mass. To correct that one, we are adding a correction factor which is called as Van Hoff factor. Now elevation in boiling point. What is elevation in boiling point? Delta TB. Delta TB is equal to I into Kb into m. What is this Kb? Kb is ebullioscopic constant. Ebullioscopic constant or molar elevation constant. Next one is depression freezing point. That is, if I add a non-volatile solute into a solution or into a solvent, the freezing point will decreases and boiling point will increases. That is what I mentioned here, depression freezing point. And what is the Kf value? Kf is the cryoscopic constant. Kf is a cryoscopic constant. And what is this m? M is molality. In the case of depression freezing point and elevation in freezing point, the concentration term that we are using is molality. Now coming to the osmotic pressure. Osmotic pressure, which is represented as pi, which is equal to I into C RT. What is the C? C is molarity. And what is R? R is gas constant. So this is all about the 4 colligative property. I will be telling you how we can apply all these things in the questions. We will be discussing the questions and everything, and thereby we can make it completely clear. Okay. Okay. Next is about Van Hoff factor. Just now only we discussed about a term which is I. And what is the significance of this I? What is the significance? That is, the molecular mass that we have found by using colligative property is not going to be its exact molecular mass when we add a electrolytic solution. What is the problem with electrolyte solute? Electrolyte solute will either undergo association or dissociation in the solution. If it undergo association or dissociation, the amount of solute particles will be changing. And we all know that colligative properties depend only on the amount of solute particle. And if we got association or dissociation of solute particle in a solvent or in a solution, there will be change in the value of molar mass or whatever things we are going to find out using colligative property. And to correct that one, we are using a correction factor which is called as Van Hoff factor. And what are the different equations you can use for Van Hoff factor I? First one is observed colligative property. Observed colligative property by calculated colligative property. One of the equation. And next one is normal molar mass divided by abnormal molar mass. If you take the ratio of normal molar mass by abnormal molar mass, that time also you will be getting Van Hoff factor. Yes. So these are the points that you have noted down in the case of Van Hoff factor. Okay. Now how the Van Hoff factor is changing with respect to association and dissociation. When there is no association or dissociation, that is in the case of non-electrolyte. In the case of non-electrolytic solution. Just a minute. In the case of non-electrolytic solution, you know that value of I will be equal to 1. When the value of I is equal to 1 means whatever the value of different property that we found out using colligative property will be correct. There is no change. Now in the case of dissociation means number of atoms will be increasing. If the number of atoms increases, value of I will be greater than 1. In the case of dissociation, value of I is greater than 1. In the case of dissociation, how we can calculate the value of I? It is equal to 1 plus n minus 1 into alpha. 1 plus n minus 1 into alpha, where n is the number of ions dissociated. And what is alpha? Alpha is the degree of dissociation. And in the case of association, the molecules will be combined together and it will either dimerases or trimerases or tetramerases. In that case, value of I will be less than 1. Okay. And how we can calculate value of I if we are given with a solute which undergoes association? That is equal to 1 plus 1 by n minus 1. What is the difference we can see is here it is n and here the n will become 1 by n. That's only the difference between these two equations. And 1 by n minus 1 into alpha. So these are the complete equations related to the Van Hoff factor and about colligative property. Okay. Hope all of you understood it very clearly. Now we can move into one more topic, which is osmotic pressure, because some conceptual understanding is required for the osmotic pressure that I will be discussing, and after that we can move into the PYQs. Yes, osmosis and biological importance. Yeah, osmosis is having a lot of biological importance. As you are all NEET students, I am sure that you don't need much explanation about these things. Okay, anyhow, I will be just telling a small idea about osmosis. What is actually osmosis? There will be, okay, let's imagine that there is a solvent and there is a solution, and this is a semi-permeable membrane. Okay, and osmosis, if I am going into the definition of osmosis, I can tell that osmosis movement of solvent, movement of solvent molecule from low concentration, movement of solvent molecule from low concentration to high, low concentration to high concentration. Okay, maybe you will be having doubt, okay, whether it is, why it is not high concentration to low concentration. That is what the normal thing, right? High to low, nobody will go from low to high, right? Yeah, how it is happening, how we can explain this one? This is a solvent, this is a solution. Okay, we know that solution means we have added solute, solution means we have added solute. If we add solute to a solvent, it will become solution. And what is going to happen to the vapor pressure? Vapor pressure will be low vapor pressure, and solvent molecule will be having high vapor pressure. Solvent molecule will be having high vapor pressure, and this pressure difference only is making solvent molecule moves from low concentration to high concentration. Okay, I am writing the concentration also. This is low concentration, this is high concentration. Low concentration will be having high vapor pressure, and high concentration will be having low vapor pressure. This pressure difference only making the solvent to molecule to move from low concentration to high concentration. Okay, now this is what osmosis. Now what is osmotic pressure? Osmotic pressure is how much pressure I have to supply here, how much pressure I have to supply here to make this pressure equal to the vapor pressure of the solvent. Then only the flow of molecule will stop. We want to stop the flow of solvent molecule. That is what osmotic pressure. And the pressure required to stop the flow of osmosis is osmotic pressure. Yes. So this is what the understanding about osmotic pressure. And osmotic pressure, if I am taking two different solutions, if the osmotic pressure of first solution and second solution both are same, then there won't be any net flow. If the osmotic pressure of both are same, then there won't be any net flow. Just note down one more point. Here this is a solution and it is having high concentration, low vapor pressure, and this will be having high osmotic pressure. That is, if any solution which is having higher concentration, which means it is having more solute particle, that will be having highest osmotic pressure. Why? Because it will be having low vapor pressure. So we have to increase this vapor pressure equal to the vapor pressure of the solvent molecule. For that we have to give more pressure. That more pressure required to stop is what? Osmotic pressure. And this will be having low osmotic pressure. So that is the reason when in the case of hypertonic solution, if I am taking about hypertonic solution, outside osmotic pressure will be greater than inside osmotic pressure. Outside osmotic pressure will be greater than inside. So the same example, outside osmotic pressure is greater than inside osmotic pressure. I am just taking these two solution. In the first one, outside osmotic pressure is greater than inside osmotic pressure. Just take this one as pi out, and this one is pi in. Now can you say what type of osmosis it is, hypertonic or hypotonic? It is hypertonic, and because of that, if I am considering this as a cell, what is going to happen? Solvent molecule will be moved from the cell to the solution. Solvent molecule will move from the cell to the solution. That is why the cell will be shrinking. And biologically we will be calling it as plasmolysis. Process. And just opposite of this one, it is called as hypotonic solution. In that case, the solvent molecule will be moving from the solution to the cell. Okay, if I am considering this as a cell. Okay, hope all of you got a complete understanding about hypertonic, hypotonic and isotonic. Got it? Now what is the last one? Reverse osmosis. What is the last one? Reverse osmosis. Reverse osmosis, if I am supplying, see here in this solution, in this hypertonic solution, I am supplying pressure on this to stop osmosis, right? And if we supply pressure which is greater than the osmotic pressure, what is going to happen? The solvent molecule from the solution will start moving to the solvent molecule, and that is what reverse osmosis. Osmosis from solvent to the solution, or osmosis from low concentration to high concentration. And if I am giving a pressure which is greater than the osmotic pressure, the solvent molecule will move from higher concentration to lower concentration. That is what we call as reverse osmosis, and it is having a very good application, that is desalination. That is in the Gulf countries in which water is having salt content, to purify pure water from the salt water, we will be using the concept reverse osmosis. Okay, hope all of you got a complete idea about osmosis and all. Yeah, so this is all about the concept of solutions chapter. Hope all of you got it everything. Now we can move into some PYQs that is asked in the previous recent years, and thereby we can make a complete understanding of this chapter. Okay, here's the first question for you. Yes, 5 moles of liquid X and 10 moles of liquid Y, make a solution. Yeah, here I am taking two liquids. First one is X, another one is Y. 5 mole of liquid X, that is number of moles of X, I can take it as 5, and 10 moles of liquid Y, NY, which is equal to 10, having a vapor pressure of 70 torr, having a vapor pressure of, okay, the solution is having vapor pressure, that is PS observed, which is equal to 70 torr, and the vapor pressure of pure X and Y are 63 and 70. Okay, I am writing that. After that I can write the total pressure. That is vapor pressure of the pure X, P0 X, which is equal to 63, and vapor pressure of the pure Y, P0 Y, which is equal to 78, okay. And which of the following is true regarding the described solution? And vapor pressure and the total pressure of the solution, PS observed, that is equal to 70. Which of the following is true regarding the described solution? This solution is ideal. Is it going to be ideal? How we can check whether it is ideal? The observed vapor pressure, if it is equal to the calculated vapor pressure of the solution, then we can say it is ideal. Solution having volume greater than the sum of the individual ions. What is this one? If the volume is greater than the individual ion, which means it should show positive deviation, and the solution shows positive deviation. Yeah, solution shows negative deviation. How we can find out whether it is showing positive deviation or negative deviation? If P observed is equal to PS calculated, then it is ideal solution. Okay, if PS observed is lesser than PS calculated, then it is negative deviation. That is, the observed one will be lower than the ideal one. The ideal one is what? The calculated one. Okay, and if PS observed is greater than PS calculated, it is positive deviation. Now we can see what is going to be followed by this particular data. We have to calculate the PS total pressure according to the Raoult's law equation. According to the Raoult's law equation, PS is equal to P0 X chi X plus P0 Y chi B, right? That is PA plus PB, or PX plus PY. Now what is P0 X? P0 X is clearly mentioned in the question, 63 into chi X, mole fraction of X. How we can find out mole fraction of X? If you are given with a solution of mixture of X and Y, number of moles 5 divided by total number of moles 5 plus 10, it is 50, plus P0 of Y 78 into 10 divided by 50. On solving this, what is going to be the answer you are getting? You will be getting the answer 78 3 torr. That is PS calculated. PS calculated is 73 torr. From this we understood that the PS observed is PS which is observed is lesser than PS calculated, which means it is a clear indication of negative deviation. Clear indication of negative deviation. Yes, this is a complete idea about this one. Hope all of you understood this question. Now we will be moving into the next question. NEET 2024. Mass of glucose required to be dissolved to prepare 1 liter of its solution, which is isotonic, with 15 gram per liter solution of urea. Yeah, isotonic means what? If the if the osmotic pressure is equal to the osmotic pressure of the solution that we are comparing, then we will be calling it is isotonic solution. Now how we can use this concept to find out the mass of glucose? That is my question. Okay, anyhow we all know that for isotonic solution pi of glucose, which will be equal to pi of urea, pi u. Okay, pi of glucose is equal to C of glucose into RT. Okay, C of glucose into RT, which is equal to C of urea into RT. Yes. Okay, here RT both are common, so I can cancel. So the concentration of glucose will be equal to concentration of urea. And anything is mentioned in the question regarding this one? 50 gram per liter. 50 gram of urea is mentioned. Per liter means 1 liter of urea is present in 1 liter of urea is present in 1 liter. 15 gram of urea is present, which means what is the number of moles present in this particular solution is what the number of moles. Is what the concentration. Whatever the number of moles present in this particular solution is the concentration. So 15 gram present in 1 liter and 15 divided by molar mass of urea, that is 60. That is the concentration of urea. And concentration of glucose, here also we are preparing it for 1 liter solution. Molar mass of glucose we already know, 180. That will be in the denominator, 180. And mass of glucose, that is we have to find out. So from this it is very clear, the answer is the mass of glucose or amount of glucose required is 50 into 180 divided by 60. And what is the answer? What is the answer? It is coming 45 gram. 45 gram. So this is my answer. Hope all of you understood this question. Yeah, I can move to the next question. Yeah, Henry's law constant. Yeah, we already discussed a lot about Henry's law constant, and the same type of question we discussed in the class. Henry's law constant, 3 gases A, B, C, they have the KH value, they have the KH value given in the question. The solubility of these gases in water follow the order. Which is the order? We know how the KH is related with the solubility. KH is inversely proportional to the solubility. So among these, higher the KH, where is having high KH? A is having high KH, so A will be having lesser solubility. Then comes the higher one is for C, then comes C, then the higher one is for B. So A, C, B is the answer. What is the option? Option B is the correct one. Moving. Got it, everyone? Very easy question. Moving to the next question. Plot of osmotic pressure versus concentration for a solution gives a straight line with a slope 25.73 liter bar mole inverse. The temperature at which the osmotic pressure measurement is done. Is the temperature you have to find out. How you can find out this temperature? Just if you as the question is related to osmotic pressure, just write the osmotic pressure equation. Pi is equal to CRT. And for a solution gives straight line with a slope. So which means there is something we should do with the graph. I will be drawing a graph of pi versus c. Pi versus c. What I will be getting? This will be equal to y is equal to mx plus c, and c is constant. So c is 0. So I will be drawing a graph of straight line which starts from the origin. And what is going to be the slope? Slope is equal to rt. Slope is equal to rt. I got the slope right. If slope is equal to rt, and this rt value is given in the question, what it is? 25.73 liter bar mole inverse, liter bar mole inverse. And from this we can easily find out temperature, which is equal to 25.73 divided by value of r mentioned in the question, 0.083. Yeah, from this you will be getting the answer. What is the answer? You will be getting 310 Kelvin. 310 Kelvin will be the answer that you are getting. And 310 Kelvin, what is the answer? 310 Kelvin is how much? Okay. Here the answer is given 310 Kelvin, not the degree Celsius. So 310 Kelvin means what is the temperature? Temperature is coming around temperature is coming around 27 degrees Celsius, right? I think this is the answer. Yes. So this is how we can solve this type of question. And next we will be moving to the next question. Which among the following aqueous solution of electrolyte will have minimum elevation in boiling point? Very simple question. Minimum elevation is boiling point. We know that elevation in boiling point delta Tb, which is equal to I into Kf into molarity. If we want minimum elevation in boiling point, that will be having minimum I into m value. Minimum I into m value. That is, Kf is not going to depend. Kf depend only on the solvent. So what is the minimum I value? I into m. I into m value for this one. M is already given, molarity is already given 0.005, and I value is 2 into 0.05, which is equal to 0.1. Next one, what is I into m value? Kc also will be dissociated into 2 ions. So 2 into 0.1, which is equal to 0.2. 0.1 molar MgSO4. Here also you can see MgSO4 will be splitting into Mg 2 plus plus SO4 2 minus. So it is also 2 into 0.1, which is equal to 0.2. Here 1 molar, that is 2 into 1, which is equal to 2. So among these, which is having lowest I into m value, that is having minimum elevation in boiling point. Yes. So we'll be moving to the next question. Yes, the following solution were prepared by dissolving 10 gram of glucose. 10 gram of glucose. I am adding 10 gram of glucose. Can I add? Yes, I will add 10 gram of glucose and in 250 ml of water, and 10 gram of urea in 250 ml of water, 10 gram of sucrose in 250 ml of water. What is this? All the 3 solute I will be adding with the same quantity in water. Okay. And the question is, right option for the decreasing order of osmotic pressure of this solution. How osmotic pressure is related for different type of solute. How it is related? We know that, okay, osmotic pressure is equal to I into C into R into T. If I value is different, then we can say that we can find out this order. But here you can see all are non-electrolyte. Urea, sucrose, glucose, all are non-electrolyte, right? Which means I value is equal to 1. So I can say pi is equal to C, and R and T both are same. So pi is equal to C. If I am saying pi is directly proportional to C. Now how we can find out the order of osmotic pressure? C is what? C is what? Molarity. And what is molarity? Molarity is number of moles divided by volume of solution. Number of moles of solute divided by volume of solution liter, and we know that this number of moles is equal to given mass divided by molar mass. Here we got the point. And given mass is same for all the three, that is 10 gram. Then how we will be comparing the osmotic pressure? That we will be comparing it by using the molar mass. So order of molar mass will be just opposite to the osmotic pressure. Molar mass order. What is the order of molar mass? Which is having highest molar mass among all these? Sucrose. Sucrose is having highest molar mass. Sucrose, our hero. P3. Sucrose having P3 osmotic pressure. Then comes glucose. P2. Then the last one, last but not the least. Who is a guy? Urea, P1. This is the order of molar mass. If this is the order of molar mass, what is the order of osmotic pressure? Osmotic pressure P3 lesser than P2. Glucose is having P2 or P1? Sorry, glucose is having P1. My bad. Then urea is having P2. So P3 less than P2 less than P1. This will be the order. So what is the answer? What is my answer? P1 is will be having greater then P2 then P3. Yeah, option C is the correct one. Moving to the next question. Are you tired of solving the questions? I am not tired, so I will continue. Okay, next question is NEET 2021. The correct option for the value of vapor pressure of a solution at 45 degrees Celsius with benzene to octane in a molar ratio of 3:2. Benzene and octane. Vapor pressure of the solution. What is this one? Vapor pressure of a solution. We know that vapor pressure of a solution PS, which is equal to PA plus PB. Okay, here A and B I am writing it as benzene and octane. Just a minute. Why the board is behaving non-ideally? Okay, PS is equal to PB benzene plus PO octane. Okay, we have to find out total pressure of solution. Very easy question. So P naught of B into what? Chi of B plus P naught of O into chi of O. P naught of B. What it is? Yeah, it's given in the question. Vapor pressure of benzene is 280 into chi B. Chi B is it given? Chi B is it not given, but the molar ratio is given. From the molar ratio we can find out. For octane the ratio is 3 by total ratio. What is 3 plus 2, which is 5, plus P naught of octane 420 into what? Mole fraction of octane, that is 2 divided by 5. On solving this you will be getting the answer. What is the answer? 336 mm of Hg. Completed. Hope all of you got a clear understanding about this question. We will moving to the next question. The mixture of solution which shows positive deviation from Raoult's law. Yeah, what is the answer for this one? So I want everyone to take a note of what are the solution which is showing positive deviation, what are the solution which is showing negative deviation, because this comes in the exam directly. In many of the mock tests I have seen this type of question came. So what you can do is just you can remember some of the positive deviation showing solution and negative deviation showing solution. And here the answer is ethanol plus acetone, and these examples are clearly mentioned in the NCERT textbook. As it is mentioned in the NCERT textbook, there is a high chance that question can come. So I am just mentioning all these things in the slide, and I will be sharing it in the group also, and you can just note it down. For negative deviation, what are the common examples which are very important for the NEET exam? That is acetone plus chloroform. This is mostly asked, acetone plus chloroform, that is showing negative deviation. And then chloroform plus aniline, water plus nitric acid, water plus sulfuric acid, phenol plus aniline, ethanol plus acetic acid. Yes, all these are the examples. We can just note a memory trick to identify it is when there is a hydrogen bond formation. When the after mixing, if there is a hydrogen bond formation, the bond will be stronger. So it is showing negative deviation. Yes. Now for positive deviation. For positive deviation, the common example you can note is ethanol plus water, methanol plus water, acetone plus water. Sorry, acetone plus ethanol. See, everywhere you can see alcohol. Yeah, what is this? Positive deviation is full of alcoholic. Ethanol, methanol, ethanol, acetone, again ethanol, ethanol, ethanol. So when we just, this is a memory trick we can use. Alcohol plus non-similar liquid. Alcohol plus a non-similar liquid, that will be majorly showing positive deviation. So these are the tricks you can use it to get +4 marks. I want everyone to get it. Okay. Next is the NEET 2019 question. For an ideal solution, very easy question. The correct option. What is the correct option? Ideal solution, delta G max is equal to 0, right? Yeah, of course it is 0. Delta G max is equal to 0. Is it? Is it? No. Delta G max is equal to, delta G mix is less than 0. Delta S mix, is it 0? No, we already discussed all these things in the class. Delta S is greater than 0. Delta V mix is not equal to 0. Is it correct? This is wrong. Delta V mix is equal to 0. So the correct option is first one. Yes, very easy question. Now the last and final question. We are going to end this section. If molality of a dilute solution is doubled, the value of molar depression constant Kf, what is Kf? It's Kf, Kgf. Is it have any relation with the Kgf? No, right, it is Kf. What is the relation between this Kf and the molality? Molality of dilute solution, if I am doubling, molality is doubling means I am increasing the concentration. Value of molar depression constant, there is no change in molar depression constant. Then how it is related? This molar depression constant Kf is not related to anything but related to only molar mass of solvent and enthalpy of fusion. It is related to only molar mass of solvent. That is, if we changes the solvent, then only the Kf or Kb or this constant will be changing, or if the enthalpy of fusion changes. Okay, so Kf is not related to anything, it is related to only solvent. If we change the solvent, then only it will change. And these are fixed properties of the solvent. Got it? That is, for a collocative constants, Kf, Kb are always constant, only depend on solvent, never on concentration. So that's all about the today's section, my dear students. Hope all of you got a complete understanding about this chapter. It's not a big chapter, it's a small chapter, but easily you can score if you have a idea about all these important topics that I have discussed today. So yeah, thank you all of you. Today I will be winding up this section with this last question, and tomorrow we'll be seeing you with another chapter. Yeah, that's all about today's class. Thank you all of you. We'll see you in the next class.